Hey everyone, today we're going to learn about parametric equations. Since I haven't had a joke in a while, let me share one terrible one with you. A kilogram in a second walk into a bar, and the bartender says, "Hey, we don't serve parametrics in here." Alright, so having said that, let's look at this. What is the parametric equation? It's when you have an input that's usually time, and that variable doesn't show up on the graph, okay? The output are actually two separate values, okay? Not two outputs for one input, it's two separate values, all right? So this is a function, but you get, two different things. So let me show you what's going to happen here. Let's say t is 0, and we're going to make, we use t as our input, and x and y are the outputs, okay? T often represents time, and that's what we'll use here. In seconds, what happens is, let's see, we're starting at 0, 0, and we walk a pace of 2 meters east per second and 2 meters north per second. That's at the same time, all right? So, but we'll consider them independently and see where we end up going with that. So if we start at 0, 0, at 0 seconds, you're at 0, 0. So our first point we're going to plot is right there at the origin, 0, okay? At 1 second, we've moved 2 meters east. And so that means east is left and right, correct? On the right, that would be 2, so 2 for x. And then we're moving 2 meters north, so that would be a 2 for the y. The point 2, 2 gets plotted right there. At 2 seconds, same thing happens, 2 meters east more, that means we're now at 4 for the y, and 2 more meters north, that's 4 for the x and then 4 for the y. That point I'll plot in green. And then you can just keep going. The next second we're now at 6, 6, and the next second we're at 8, 8. And you notice what shape this makes. It makes a straight line. So we'll connect those. The equations from this situation would be, we write it in terms of x and y being the output. So here I'm writing x as a function of time, where t is the input. And so the equation is 2t. If you plug in 0, you get 0. You plug in 4 at the very end there, you get 8, just like we calculated. And so, yeah, input is there, output's there, 4 and 8. For the other side of the function, this is just one function, but the other side of it is y. We would plug in 4 again, and we'd get 8. So that's actually the exact same function, 2t. We have two different places where the output comes out, that's x and y, but it's still just one output, the point 8, 8. All right. So input is time here, one value, and the output is a point, or two values. All right. I want you to try this next one. I can get you started on it. So if I say you start at time -2, 3, at time 0, that's where we're going to start, okay? Where t is again in seconds and x and y are in meters. So we start at x is -2 and y is 3. I'll plot that point there, -2, 3. And we're walking this time 1 meter south per second. So let's consider the y. That means I went from 3 to 2 if I went 1 meter south. And then 3 meters east, which means I go from -2 to +1. So I plotted the second point for you there. Go ahead and you finish out that table and plot those points and see what happens. And the last thing I want you to do is try writing an equation for it. You can check your equation at the end with whoever you have there. So we can check the equations at the end, but make sure I want you to see if you can try to write these. They're a little bit tricky. Some things to notice about this. First of all, time is not visible on the graph. You don't see the time unless you can visualize the points being plotted as we're doing, which I think is really helpful. Another interesting thing is that rate is in meters per second, but it's not the slope on the graph. The slope is different, okay? You saw in our first problem, 2 is the slope, or 2 is the rate, 2 meters per second, but that is not the slope. The slope was 1 on the first one. And so I want you to think about where is it, or where can you find the slope from the equations. And the last thing is, clearly we've been plotting the points. That is by far the easiest way to graph these. We're going to use Desmos later, but Desmos sometimes hides that, and I want you guys to understand how it's working, each point being plotted as we go. So, Yeah, let's try another one. So here, this gets a little more complex. I'm going to have you guys plot this into Desmos and show you how to do that. In Desmos, you can't type the x of t equals and the y of t equals, though. You have to type it like this. So you plot points using x, y. And so like if you were to type in 3, 2, go ahead and pause the video and open up Desmos to try this. Type in 3, 2, you get 1 point exactly on 3, 2. So we're going to plot them by typing in the x function, comma, the y function, and all of that in parentheses. All right. So let's go ahead and open up Desmos, and I want you to type that function in there. Okay. That is our function here of x of t equals 6 sine t and y of t equals r squared over 5 plus 2. This, the green up there, is how you would type that parametric equation in. And a side note, you do have to always use t. That's the way Desmos recognizes that it's a parametric function. And I want you to change the domain to 0 is less than or equal to t, which is less than or equal to 2 pi. You can't type pi into the domain, I know. So go ahead and just type 6.28. That's 2 pi rounded. So once you plot it, you should get something that looks like this. Now I'm going to plot the points first, and I'd encourage you to do the same when graphing it. And then it's just a matter of connecting the points. You should get something like that on your Desmos. Make sure, go back and double check all the values if you didn't get that. So we can answer these questions. The first question being, where is the person when time is 0? Well, at time 0, we want to plug in 0 into this equation for x to find the x value. 6 sine of 0. Well, sine of 0 is 0, so the x value is just 0. If you plug in 0 into this equation, 0 squared over 5 plus 2, you get 2. So at time 0, at the start of this event, whatever it is that's happening, if someone's just walking along this path, then they are at the location 0, 2, which might mean 2 meters north of something. I'm going to call it the origin because that's what 0, 0 is. But if you have some landmark or some reference, like 2 meters away from the door, that works as well, and it depends on your situation. And usually you'll have more context for that. So where's the person when t equals pi over 2? Well, let's make that the next point in our table. Pi over 2. Again, I'm going to plug in pi over 2 into this and this right here. And when you plug it into 6 sine of pi over 2, since sine of pi over 2 is 1, you just get 6. Pi over 2 squared over 5 plus 2 is 2.49, and you get those two values right there. So the location, where's the person? They're right there on that point. You see right there that I marked. And yeah, that's helpful to visualize, and then you can say, oh yeah, they are at the location 6, 2.49. Which would mean 6 meters to the right of the origin and 2.49 meters north of the origin, or above the origin, however way you want to say it. Yeah. So last question, at what time is the person directly above where they started? That's this location here. Well, you can imagine if the x value is 0 for that, that next time is going to be pi because sine of pi is 0. And sure enough, if you type in pi and plug it into these two equations, you get 0, 3.97. So, but I asked, what time is this? So not 0 and not 3.97. The time is actually pi, okay? Pi seconds later, sort of 3.14 seconds later, okay? And be very careful about, I gave you an output and we're looking for an input this time. You can go ahead and fill out those last two, 3 pi over 2 and 2 pi. You can plug them in, or I will show you in class when we get there a way to have Desmos graph this, because again, you can make a table with this, and that's doable. I think that's a little tricky. And you can also make a point that becomes a slider where you can move it along and see where the person's walking out, which I think is even more helpful. But again, I'll show those to you in class. So I'd like for you to try this one here in class. Go ahead and graph it on Desmos, and make sure you're careful about making the domain correct. And lastly, I want you to play around with it and find 2 cool functions before coming to class, okay? The way you're going to get good at this stuff is just playing around with it, and we are definitely, we're going to have some fun making some videos in a little bit, and you will have a lot more fun making the videos if you have a better understanding of what's going on. Thanks for watching, and I hope you learned something.